Okay guys, so we are starting this atomic and molecular physics quick revision. As you know that your examination is on 8th of June, so keeping that in mind, we'll try to give you a quick overview or quick revision of atomic and molecular physics. So let's start with the first part, Bohr's atomic model and hydrogen like atom. So what are the main postulates in Bohr atomic model? You know, in 1913, this was the year 1913, Niels Bohr gave his Bohr's atomic model, and this Bohr's atomic model was based on three postulates. Okay, what was the first postulate? The first postulate was that we have an electron and we have a nucleus, and the electron revolves around it under the action of the Coulomb attraction. Okay, this nucleus attracts this electron, and as a result the electrons are able to revolve around the nucleus. So this was the first postulate, electron revolving around nucleus under Coulomb attraction. Okay, this was the first postulate. Number 2, this electron cannot arbitrarily move in any of the orbit. It can only move into some specified orbit which are known as stationary orbit. So only those orbits are suitable for the electron, for which this condition L is equals to mvr is equals to nh by 2 pi is satisfied, where these n values are 1, 2, 3. I am not writing everything as we are trying to cover it quickly, so I am just writing the main things. Number 3, when revolving around the nucleus, electron does not emit any radiation. It only emits radiation whenever it makes transition. Let's say if it is here and if it wants to go to some other higher orbit, okay, higher energy state, then only you can give some energy and the electron can be promoted to the higher state. Or another possibility, that if the electron is already in a higher state, then it can come to the lower state by emitting some energy. So energy transition will happen only when the electron will change the state. So let's say if you have an energy state EI for the electron and the final energy state EF, then if some electronic transition it happened, then to go to higher state you need to give some energy, and if it is coming down to a lower state, some energy will be emitted. So EI minus EF will be given by EI minus EF by H will be the associated frequency. This energy difference will be equals to this H nu. Okay, so if EI is greater than EF, then there will be this emission, otherwise it will be absorption. So these are some basic postulates taken under Bohr's atomic model. Now what is the use of Bohr's atomic model? Bohr's atomic model is mainly used to explain one electron atom. Okay, one electron atom means there will be only one electron. The number of protons may be different. So some of the elements are some of the atoms like 1H1, it has one electron, okay, one proton, no neutron. 1H2, 1H3, these isotopes of hydrogen, they have only one electron and one proton and varying neutron. That is why they are explainable and they are called hydrogen like atom. Then He plus, although the Z value is 2 here, but the number of electron is 1, so that is why this also one electron atom. Lithium 2 plus, beryllium 3 plus, and so on. So all these atoms or ions, they have only one electron, so these are one electron atom, and on these one electron atoms or ions can only be explained by this Bohr's atomic model. And as you can see in this figure, this previous thing is shown or explained. This V is equals to EI minus EF by H, it is pictorially shown here. Now if you talk about the energy state, if you talk about the first energy state of hydrogen, it is ground state minus 13.6. If you go to the n equals to 2 state, it is some energy state will give you. N equals to 3, higher excited states will be giving you. As you go to higher n, the energy difference will keep on reducing from ground to first excited state, from first excited to second excited, second to third excited state. The energy difference, as you can see, it is increasing. So it is pictorially represented in this way. Now let's talk about this hydrogen like atom. So as I told you, whenever we are talking about this hydrogen like atom, it one nucleus we consider and the electron is revolving around it. Okay, so Coulomb attraction is responsible for this, and whenever something is revolving in a circular orbit, some kind of centrifugal force will be acting. The centrifugal force, if you take mass of the electron to be m, so mvn square divided by Rn. So this is the centrifugal force. This should be equals to 1 by 4 pi epsilon naught Jd multiplied by E divided by Rn square. We are calculating it for a general orbit, okay, nth orbit. Now what you are doing, you are multiplying m r square on both sides. So if we multiply m r square, so m square vn square, basically m Rn square divided by Rn, this is equals to 1 upon 4 pi epsilon naught Ze square divided by Rn square into m Rn square. So we have multiplied both sides by m Rn. What is this? From the postulate we know this is L square. L square is equals to nh by 2 pi. So nh by 2 pi whole square into 1 by Rn. This is equals to Ze square m divided by 4 pi epsilon naught. From this we can get the value of Rn, radius of the nth orbit, that is equals to n square h square epsilon naught. This 4 pi getting cancelled and one extra pi will be there. So pi m Jd square, where n runs from 1, 2, 3 and so on. So from this we can see that Rn is proportional to n square. So this was an important proof, like how the radius of different orbits varies with the principal quantum number n. Now if you consider for hydrogen atom, a specific case, if you take for hydrogen atom, what do you get? For hydrogen atom, you know that the Z value is equals to 1, and if you take the ground state, so n equals to 1. So if you put these values in this expression, you get Rn is equals to h square epsilon naught divided by pi m e square. Okay, now h is the Planck's constant and other values are already known. If you put this value, you will get around 5.27 into 10 to the power minus 11 meter. So this is nothing but 0.53 angstrom. So the radius of the first orbit is 0.53 angstrom. This is also called Bohr radius. Okay, and what about Vn? Rn is proportional to n square we have got. If I want to calculate Vn, then how can we calculate? We can calculate it easily from using this assumptions that mvn Rn is equals to nh by 2 pi. From this we can easily calculate Vn. Vn is equals to nh by 2 pi m Rn. Now this is equals to nh by 2 pi m. Rn value we have already calculated. Now we can directly put that Rn value. You can see what was the Rn value, n square h square epsilon naught divided by pi m Jd square. So this will give you the expression for the velocity, that is equals to Z square, some pi m will get cancelled, divided by twice n h epsilon naught. This n is equals to 1, 2, 3 and so on. In this way we can get the expression of the velocity of the electron in the nth orbit. Okay, let's say if you want to calculate the total energy of the hydrogen atom, to calculate the total energy, what you need to calculate? We need to calculate the kinetic energy as well as the potential energy. What will be the kinetic energy? Standard formula half m v square means Vn square. So v square we have got this value Z square divided by twice n h epsilon naught, this is v square, plus what is okay, this is kinetic energy, let's keep it as it is. Then what about the potential energy? Potential energy equals to minus Jd into E, so Jd square divided by 1 by 4 pi epsilon naught Jd into E Q1 Q2 by R. R we have got n square h square epsilon naught divided by pi m z E square. Fine. So you got the kinetic energy and potential energy. So what about the total energy? Total energy is sum of kinetic energy as well as potential energy. So this will give you m z square e to the power 4 divided by 8 n square h square epsilon naught square minus m z square e to the power 4 divided by 4 n square h square epsilon naught square. So this will finally give you to minus 1 by 8 into m z square e to the power 4 divided by n square h square epsilon naught square. Okay, so you can express it in terms of Rydberg constant, that is minus m e to the power 4 divided by 8 epsilon naught square c h cube c into z square hc divided by n square. This whole thing is the Rydberg constant by considering the infinite mass, and as you can write En is equals to minus r infinity z square hc into 1 by n square. So all of these things, if you to consider to be constant, we can say that the energy in the total energy in the nth orbit is proportional to 1 by n square. So in this way we get to establish for the total energy of hydrogen like atom. If in particular, if you consider hydrogen, you have to consider z equals to 1, and r infinity you can calculate 1.097 into 10 to the power 7 meter inverse, and as a result you will get the value of En to be minus 13.6 by n square electron volt. So in this way you can do this thing. So in the next video we will be talking about some problems maybe or some other concept. So before I stop the session, let me tell you guys, this unacademic goal is going on. Stay ahead in your preparation journey. You can get 20% off plus up to 1 month free extension on CSIR-NET subscription. This offer is valid till May 31st 2023. You can target for June 2024 or December 2023 at this price. So this is a great offer, guys. If you are willing to take the subscription, you can take it using this referral code Physics Hub to get the maximum benefits. And guys, you can follow me on Unacademy Plus. You can utilize this referral code Physics Hub for getting the subscription. All the 9 units are available to cover the CSIR-NET Physical Science syllabus. One subscription using our referral code Physics Hub will enable to watch the live and recorded classes of all the educators, including me, under CSIR-NET category. And a lot of benefits are there of taking Unacademy Plus subscription or Iconic subscription. You can see you get daily live classes, part length, full length assignment, and daily syllabus, and many other things I have listed here. You can pause and read. So this is all for this video, guys. Thank you very much. If you are new to this channel, please subscribe to the channel and don't forget to press the bell icon. Finally, thanks for watching.